Hello and welcome to some more Maths with Mr Thompson, and today we're going to look at a very basic but very important part of mathematics, straight line graphs. Before I get into the kind of geometry of it, let's just consider some of the actual uses of it. What I'm talking about here is we're modelling real life situations. Imagine you've got someone, a tradesman perhaps, who charges $40 for a call out fee, and then $30 per hour after that. Now, if you were going to do a graph of how much he charges, you'd have $40 starting off, and then be going up every hour another $30. You know, that graph would basically be a model of his charging structure. Or something like in medicine, maybe you're taking some medication and you start off with 40 milligrams at first, and then 10 milligrams every 2 hours. Again, you could model that by having a starting figure. I've chosen 40 again, just coincidence, and it goes up by 10 every 2 hours. So it's a way of modelling real life situations. So when we're looking at it in terms of an XY axis, there's two real things that we really care about. One is where it starts off at, that initial value when the time is 0. And two is how quickly it goes up. So in this example here, I'm starting at 3, and every time I go along 2, I go up 1. And I'll just keep that going back the other direction there, okay? So what we have here, we've got a starting figure, and we've got a rate of increase. And if you think back to our previous two examples, there's our starting figure, there's our rate of increase, there's our starting figure, there's our rate of increase. So we're looking for a straight line rule that will model this. And the rule that we tend to use, you've probably seen it before, you use it in terms of x's and y's to keep it general, is y equals mx plus c. What we're saying is any y value on a graph is equal to the x value multiplied by this thing and added to that thing. This thing being the rate or the gradient, and that being the initial value. So if we to draw this line, my initial value would be here, and my rate or the gradient is how much that increases by. The gradient we define by taking any 2 points on the line. Any 2 points, and measure that distance there, and that's the run. That distance there, which is the rise, and the gradient equals rise over run. So, if we're asked to sketch a graph, and we're told the gradient, the equation of the graph is y equals 3x plus 2, what that means is we're starting at the value 2 here, and we're going to go up 3 for every one we go along. So if that's 1, 2, 3, 4, then we're going to be at 5 the next time we hit that line. It's going to be flying up there, away up here. The line will look something like that. That value 2 is that value 2, and the gradient is 3 divided by 1, which is just 3. for a straight line, standard form, beg your pardon, of a straight line is y equals mx plus c, and that's the gradient, and that is the initial value, which is actually where it cuts the y-axis. Okay, and that's a basic refresher on the gradient of a straight line.